Hello, we are now presenting the datasheet project of the LM339 integrated circuit. I am Pedro Bon.
I am Jaqueline.
I am Danielle.
So first, a general description of this component. Well, as you can see, this integrated circuit, it is a set of 4 voltage comparators or operational amplifiers, which displayment will be explained later on the video. Voltage comparators, as its name explain, is a component that has the ability of discerning 2 tension levels applied on one's inputs. The main characteristics of this IC is that it requires very low supply current. The supply voltage has a wide range of acceptance. It has a low input bias current and a low input offset current. And some of its features is that they are very precise comparators, which means the output will change levels as soon as the variable voltage level change to higher or lower than the reference. Offset voltage has a shy drift due to temperature rising. It has sensing near ground, and it is compatible with all forms of logic such as TTL, CMOS, and MOS. And also, it has a low power requirement, so that the use of portable supply sources, such as batteries, is possible.
Well, now I'm going to present to you the schematic and connection diagrams of this component. First, in this image site, we have the schematic diagram of the internal equivalent circuit of a single comparator of the LM339. In this circuit, we have these current sources, some Darlington configurations, the diodes to make sure that the current passes in only one direction, and the non-inputs and inverting inputs, and the outputs. And when we apply an analog signal in the non-inverting and inverting inputs, the comparator circuit, as the name says, will compare these two analog values. In the positive input, if the positive input is greater than the negative input, the output will swing to the logical 0, and this will make the open collector transistor, in this case the Q8, to turn on. And when the inverting input is greater than the non-inverting, the comparator output will swing to the logical 0, which means that the open collector transistor has turned off. And as you can see in this image, this circuit consists of an operational amplifier with an open collector output transistor, which gives us a logical signal in the output, that is 0 or 1. And here we have the connection diagram of this IC. In this image, we can see that the pinout, and we have the pinout and what each of the pins represents. And this component has 8 inputs, 4 output, 1 supply voltage, and 1 ground. And as Pedro Bon already said, it has 4 independent comparators inside of it.
Now, the absolute maximum waveforms. Calma aí. Ah, meu, fechou o negócio, peraí. Tá. Understand the absolute maximum rating is absolutely critical to ensure the reliability of the device in the application. These are the extreme capabilities of the device and are never to be accessed under worst-case conditions. Otherwise, the LM339 might fail. In the first column, we have ratios. In the second, the symbol. In the third, its value. And in the last, the united. Power supply voltage plus 36 or plus 18 VDC. Input different voltage range is 36 VDC. Input common mode voltage range minus 0.3 to 6 VDC, output short circuit to ground continuous, input current 50 milliamperes, power dissipation uh, temperature 25 degrees Celsius, plastic 1 watt, and the rate above 25 degrees Celsius is 80 milliwatts for ground Celsius. Junction temperature 150 degrees Celsius. Operation ambient temperature range 0 to plus 70 degrees Celsius. And storage temperature range minus 65 to plus 150 degrees Celsius. And the last, the electrical characteristics: input offset voltage, typical 1 voltage, 1 millivoltage, and maximum 2 minus or plus 2 millivoltage. Input bias current, typical 25 and maximum 250 nanoamperes DC. Input offset current, typical 5 and maximum 50 nanoamperes DC. Input common mode voltage range, minimum 0 and maximum V plus minus 1.5 VDC.
And in the supply current, we have a typical value of 0.8 milliampere DC and a maximum of 2.0. In the voltage gain, we have a minimum value of 50 voltage for millivoltage and a typical value of 200. In the large signal response time, we have a typical value of 300 nanoseconds, and in the response time, we have a typical value of 1.3 microseconds. And here in the output sink current, we have a minimum value of 6 milliampere DC and a maximum value of 16 milliampere DC. In the saturation voltage, we have a typical value of 250 millivolt DC and a maximum value of 400. And finally, in the output leakage current, we have a typical value of 0.1 nanoampere DC.
And now we will explain some examples of typical applications of this integrated circuit. First of all, we got an AND gate, which is a logic gate. And we can see that in the inverting input, we have a fixed voltage, a set voltage of 375 millivolts. In the non-inverting input, we see 3 inputs and 1 resistor to ground of 1K ohms. Due to parallel and series phenomena, the tension on the non-inverting input will only be greater than in the inverting input when all 3 of the inputs are on high, and it will then have the same working principle as a logic AND gate.
And here we have the second example, that is a square wave oscillator. The LM339 oscillators are appropriate for frequencies below several megacycles. And in this circuit, the output frequency is set by resistor 4 and capacitor 1. And the total hysteresis of the loop is set by resistor 1, 2, and 3. To analyze this circuit, we assume that the output is initially high. For this to be true, the voltage at the negative input must be less than the voltage at the positive input. Therefore, the capacitor C1 is discharged. The capacitor C1 will charge up through resistor 4, and when it has charged up to a value greater to the non-inverting input, the comparator output will switch, giving us a logical 0. Then, the capacitor C1 must now discharge through resistor 4 towards ground. The output will return to its high state when the voltage across the capacitor has discharged to a value greater than the inverting input. And this way we have the signal oscillation of the output, having, and this way we have a square wave oscillator with the LM339. That's it. Thanks for your attention.